So, welcome everyone. This is the first lecture of our 10-day lecture series, which is titled as MATLAB based modeling. Of nonlinear, parametric, stochastic oscillator system. Okay, so before proceeding, let me just introduce me first. So, I am Jayadekar Mundal. So, I am a PMR scholar in the Department of Physics of IIT Kanpur. And so, let me also tell you what is the motivation of doing this course. So basically, I work in the field of MEMS, which is nano electromechanical resonator system. So I basically work with 2D materials. So in my case, I work with graphene and silicon nitride. And so what I do is basically I study the vibration of these 2D materials under different kinds of drive conditions. So large part of my PhD work is basically implementing is exploring different kinds of oscillatory system in MATLAB. So for example, so we have this circular graphene membrane, and this graphene. So when I work with this graphene membrane, I call and if I look at the response in the frequency domain detected for it, so I usually get these kinds of things. So each of this each of them can be treated as an harmonic oscillator, and graphene is nonlinear. So all of these modes, they are nonlinear harmonic oscillators. So that is why in my case it is important to know the how to model these kinds of nonlinear oscillator system in MATLAB. So that is why I thought it will be useful for a large number of people. So who want to model nonlinear oscillator system in MATLAB. So I will divide the whole course in two parts. So the first few lectures, for example, the first five lectures will be on the basics of MATLAB. So first part, initial five lectures, that will be on the basics of MATLAB or fundamentals of MATLAB. So what we will cover? So for example, today, so the day one we will basically we will basically do the introduction to MATLAB environment. I mean, we will learn how to use the command prompt, how to use the script, how to uh, use the whole MATLAB environment, and how to create also an account in MATLAB online if someone doesn't have access to MATLAB. Then we will learn about data types and variables. Then we will learn how to define an array and what and its mathematical operation. So this is what we will learn in the first day. In the second day, then we will proceed with conditional statements. So what are conditional statements? So uh, whenever you want to check something, so every time you make a decision. So for example, if it is raining, then you will go with an umbrella. So that is kind of you have to make a decision. So for so if you want the computer for you to make some decision, for example, if you want the MATLAB environment to make decisions for you. So for example, you want to check if a number is prime or not. So if you want to check that, you have to give the computer some condition which the computer will check, and if that is if the condition is satisfied, then it will do some certain operations. So that is basically conditional statement. So it so we will learn if, else. So this is the conditional statement. So if it is raining, then we will take the umbrella. Else, we will not take the umbrella. So we have this kind of statement. So that is usually checked with usually checked with this conditional statement. Then we will proceed with loop. So this so what is loop? So loop is when we loop is basically written in any programming language when we want to do some certain task iteratively. So for example, we want to add, we want to the square of all the of all the integers from 1 to 10. So what we have to do? So basically, we have to first square the first integer number. Then we have to take the second integer and square it. Then we have to take the third integer and square it. And in that way, we have to go up to 10. If you want to do up to 10, or if you want to do up to 50, then you have to go up to we have to square each of the integer number from 1 to 50 and square. So that means we have to do the task of squaring iteratively. So that usually written in with the help of this loop. So it can be loop can be of various types. So we can have for loop, we can have while loop. So and other also. So we will learn that in our second day. So this conditional statement and this loop, these are the core of writing any program, be it in MATLAB, Python, C, or whatever. So we have to learn it very so concisely. And after that, in the third day, so in the third day we will learn how to plot data. So plotting, so we will explore plotting. It will be in 2D plotting, 3D plotting. We will learn how to define functions. We will also learn about how to use the curve fitting toolbox in MATLAB. So we will learn more details in each about them in each day. So on day 4, we will learn about interpolation. So what is interpolation? So for example, we have this data set for these are the data points. And suppose for so this is the corresponding x and this is the corresponding x. So these are the corresponding x values for each of the data sets. Now suppose we want to know what is the value of y for this x. Suppose this is x equal to xm, and we want to know for x equal to xm what is the value of y. So if we know the functional form, so for example y equal to sin x, if we know that, then we can put the x equal to xm and that will give us the corresponding y value. Fine. But what if that data is coming from a real experimental scenario, or suppose we have a census data, population data, so we don't, where this interpolation is useful, where we don't know what is the functional form. So interpolation is used to know what is the value of this dependent variable, which is y, for for this x equal to xm, which is not present in the data set. So these are our data points, and using these points we want to know what is the value of y at this point. So that we can do with the help of interpolation. So we will learn how to do that. So there are different kinds of interpolation method. We will learn integration, how to do the integration in MATLAB. We will learn about differentiation. So these things we will learn on in day 4, and on day 5. So we will use this basic integration and differentiation concept, and we will learn how to solve higher order differential equation. So our ultimate goal is to model the stochastic nonlinear harmonic oscillator. So we know that if we consider a simple harmonic oscillator also, that equation can be written as d2x dt square to minus omega square x. So this itself is a second order equation. So we want, so in the day 5 we will learn how to solve this second order differential equation in MATLAB. So this will be this is how we will proceed with the first part. So where we will just uh, uh, learn the basics thing, and building on this these things we will explore the next part. So whatever it is, I mean, if you are new to programming, that's also fine. If you have some basic fundamental basic knowledge about programming and you want to strengthen this part further, that is also fine. And so this is the first part. And and then the next 5 lectures, that will be the our second part. So day 6 we will learn about duffing. And van der Pol oscillator system. We will learn how to explore. We will explore their phase space. We will learn what is phase space, and we will also learn how to plot them, how to get the phase space, do the plotting of phase space in MATLAB. So based on the materials of the first 5 days, so we will do these things. So next, and if time permits, maybe I will also uh, show some chaotic uh, behavior also, presence of chaos in this system, so if time permits. And then on day 7 we will learn about how to do the FFT. So if we will learn about how to do the Fourier transform. So why this is important? Suppose we have the time displacement data of the oscillator with time, and in real world scenario, so it doesn't exactly look like sine curve. So when so it doesn't exactly is a sine curve. So when you are doing experiment, so there is noise present in the system, thermal noise, and there can be damping, different kinds of damping, and depending on that, the system response can look like this. So so now suppose you want to know what is the frequency with which the system is oscillating. So for example, if you want so if we want to know the damping, what is the frequency, then just by looking at this, it is not easy to tell. So what will be the frequency? So we have to take the oscillator model if we know the model, and we have to fit with it, and from the fitting function, which we will discuss in car fitting toolbox. From the fitting function, we have to extract its frequency. So that is possible when we are sure of the model. But when you are not sure of what the model is, so then what you can do, so if we have the time series data, time data of displacement, then we can use the Fourier transform. We can Fourier transform it, and we can look at it in the frequency domain. So if this is from the frequency domain, we can tell what will be the frequency of this oscillator and what is the damping of this oscillator system. So by using this FFT, we can extract its physical parameters. So we will also learn about that. So extraction of physical parameters. So for example, damping, frequency. So that we will learn how to do. And we will also explore the damping hysteresis in day 7. So what is damping hysteresis? So we know that if we have a harmonic oscillator, simple harmonic oscillator. So if we and this is the response in frequency domain. And now if we increase the drive amplitude, so it will uh, perform oscillation with larger amplitude. So if this is linear system, so what we will see with increase drive strength, so its maximum amplitude it will increase linearly. So if this is drive strength and this is max amplitude, so there will be a linear relation. So this is for increasing drive strength. Now, if we have a nonlinear system, then what we will see? So that we will see that for very small value of this drive strength, the system response will look like this. But after a certain amplitude of drive strength, we can see that there will be this certain jump, and depending on in which direction we are, so if we sweep the frequency, then we will see that its response will look like this. So we will learn how to do this, how to simulate this in using MATLAB, and what is the what is the significance of this types of graphs? So for damping oscillator system, from the area of this you can know what is the non-linearity of the oscillator. So by uh, looking at the So by looking at the area of the hysteresis curve, you can tell what is the nonlinearity of the system. And then we will proceed with on day 8. So we'll learn about parametric excitation. So we'll basically explore the Matthew equation. So Matthew equation is basically we have this damped harmonic oscillator system, and here in the frequent we are modulating the frequency term with a function of time, and we have this damping factor, and we have this drive. So what is the this Matthew equation? So in the we are modulating the frequency here. So it can be a function of time. So I mean we can drive it with twice of the drive frequency. This ft can be a sine 2 omega 0 t. So the frequency that we are modulating with twice of the frequency. So if and we can also I mean we can do the drive with omega 0 by n. So I mean we can drive it with a lower frequency, we can drive it with a higher frequency. So this two case is quietly is known in nonlinear dynamics literature, and in if we drive it with twice of the drive frequency, so in that case we will observe uh, some instability, and we will observe some unknown time kind of behavior. So we will learn about that, and we will also learn about some advanced plotting method. And then on the day 9, so you learn about how to model a stochastic oscillatory equation. So here we will learn about what is additive noise and what is multiplicative noise, and which case we can use for solving which kind of system. So what I mean so the harmonic oscillator equation you use. So what is stochastic system? So if your system is present if your system is in contact with some thermal body. So for example, if that is a so in our case we have this graphene system, and that is present in room temperature. So room temperature means you will have some air molecules which will interact with the membrane. So that means it is present. So there is this thermal noise present. So if there is noise term present, so we cannot use our conventional differential equation solving method. So for example, we will learn about RK4 Euler method. So these are the methods for a system which is deterministic. So that will not have some stochastic part. That will not have noise present. But if we have noise in the system, so in that case you cannot use the you cannot use RK4, or you cannot use Euler method. So you have to use some other method. So which we will discuss, and we will simulate some oscillator in presence of noise, and we will look at how its response will look like. And in the last day, so we will do some advanced signal processing method using MATLAB. So there I will discuss uh, how to how can you mimic the condition that an device usually do to detect something. So for example, so we use some lock-in in our setup. So what it does, it basically, so if we have a harmonic oscillator system, if we look at suppose we have an oscillator system, then we can write down its response as a cosine of omega t and b sine of omega t. So lock-in, this lock-in apparatus, what it does, it basically uh, it can extract what is the A and B. So that means it can extract two quadrature components which are perpendicular to each other. So if we look at cos omega and sin omega, so they're 90-degree out of phase. So this we can generally call as in phase component, and this is out of phase, or you can call it otherwise. So from lock-in, so we can detect what is this A and B, and we can, we can store it, or we can see its variation with time. So in MATLAB also we can mimic what the working principle of of this lock-in. So and from that, and using this low pass filter, we can exactly also look at these components. So we will learn about how to do that in MATLAB. So we will learn about lock-in detection, principle implementation in MATLAB. So this is the structure of the course. So on the initial 5 days, we will just go through the basics. We will learn this conditional statement loop. We will learn how to do the plotting, how to do use the curve fitting toolbox, how to define a local function, how to do interpolation, integration, differentiation, and then we will once we are well equipped with solving this higher order differential equation, then after that we will on the next 5 days, on the last on the second phase, we will just focus on this on simulating this non-linear oscillator system. For example, Duffin, Van der Pol. We will learn how to look at them, how to do the Fourier transform, how to extract meaningful physical parameters from the data, how we will explore Matthew or parametric excitation, which is very well studied in nonlinear dynamical systems. We will also learn about how to solve stochastic oscillator equation, and we will also just for like the last day we will do some advanced signal processing. How can you mimic the lock-in detection principle in MATLAB? Okay, so with this, let me proceed with how to open an account in MATLAB online. So I will first show how to open an account. So if you have license, so you can work with your MATLAB uh, software. But if you don't have access to MATLAB, and if you want to, work with it, so you can create an online account in MATLAB, which is a free version, and it gives 20 hours per month for free. So let me just guide you how to do that. So you have to type MATLAB online. So and here you have to open an account. So first you have to click on the sign in. So where you have to create go to create account. So I have my account. So I will try with my Gmail. type your email ID here. Then you have to to access your organization. So if your organization has license, so you can download the software with which you can work offline, and there is no time limit. But if you don't, if your organization don't have any license, and if you still want to work with it, so you can uh, try this online basic version. So the content that I will discuss in this in this in all the lecture series, so that can be easily done in this online function. So you have to uh, create a password here. You have to click on next, and there you will have to enter the code. So let me check my code. Let me enter it. Yeah, and here you have to write down your name, location, and here you have to fill all the slots. So department, I will choose physics, and this is graduate level. Yes. So fill out all the details, and you are good to go. So in this way, you can create your MATLAB account. So once you have created your MATLAB account, so you can click on this MATLAB, and here you can see use MATLAB Online Basic, and you can also have so if your organization has license, so you can link your license here, and you can download MATLAB, which you can use unlimited. If you don't have license, you can use this MATLAB Online Basics, which we can use online up to 20 hours per month. And you also have this 30-day MATLAB trial, so you can use this online and offline also, which is unlimited. So for now, I will just go to this use MATLAB Online Basic. So if you click on this, so let it load it. Yeah. So here you can see a window popped up. So here you have this section, you have this and this. So what are this? So basically, when you are writing a code, you have to write it in a script. So for that, you have to go to the new script, or you can go to new, and here you can see a lot of things. You have script here, live script. You can define a local function, you can define a live function, and all this. So first I will start with script. So if you click on the script, so here you can write your code. And so let me just, so when you're writing a code, you want to save it so that you can access it later. So for saving, you have to go to save, and you have to click on the save. So MATLAB files are generally extension is .m, and here you have to give the name of the code. So while naming, you have to be cautious. So little bit cautious, like, so there are some inbuilt functions in MATLAB, and the same name you cannot use. So for example, MATLAB has a sine function. So if you want to name it sine, or MATLAB has for function. So if you want to name it for, and if you save it, so that will not run properly. And if, so for example, MATLAB has a square root. I mean, if you give a number, it will give you a square root of that number. So that is generally inbuilt function in MATLAB, and that is sqrt. So if you save something with that name, so it will give also the warning that, and in the warning, so let me just show you first. So yeah, if you save it, so you can see the warning that function square root has the same name as a MATLAB built-in. So we suggest you rename the function to avoid a potential name conflict. So that's what you have to be careful while while saving a script. If you save it with a function name, so which is a MATLAB built-in, so it will give you a warning, and so it will, I mean, it will give you some potential error when you will run that. So you try to avoid that. So be cautious while naming any function. So I will just again, so let me just leave it. And if you want to open another script, so for that again you have to go to new and go to script, and let me save it with some decent name. So suppose you want to so let me just give it a name, problem 1. So in MATLAB, while naming, so there are certain things. One, you cannot give the name of a built-in, and second, you cannot give a space to the name. And the third one, you cannot. Uh, okay, so you can see here, file name must start with a letter and can only contain alphanumeric characters underscore. So you cannot save it in that way also. I mean, you cannot put a number in the first. The first one should start with a letter, and there should not be any space. So this seems to be a decent file name. So we can save it. Okay, so here you can see that all the, so you have this MATLAB drive folder, and under the folder you have this scripts which are saved. So if you want to access them later, so let me show you. I will just close it and again open MATLAB to show you that it is saved there. So MATLAB online, let me go to, let me click on the MATLAB, open MATLAB online basic. Yeah, and there you can see that both are set. And what is this workspace? So it is generally, it shows you all the variables that you have stored. So what are variables? So for example, if you have a number, for example, if you want to store a number to a variable, so that you can work with that. So for example, you want to define the temperature, and you want to define the temperature in Celsius, and you want to define a rule, and you know the rule through which if you give the temperature in Celsius, it will give you temperature in Fahrenheit. So what you want to do, so generally the logic is you want to take an input from the user that give me the temperature in Celsius. I will work with this conversion formula, and then I will give you the output. So I mean, you want to have a variable as which will be assigned to the temperature. So so let me write that variable as a. So suppose the temperature is 35 degrees Celsius. So if you run it, so let me run it first. So you can see here that a is 35, and here you can see in the command window. Let me just, and if you press Control plus plus, then it will just increase the size. So you can see that when you are running the your script, so that 35 is stored to A, and that is shown in the command window. So if you want to do some quick check, so for example, you want to you can write in the command window also. Suppose you want to assign the 30 to a variable b, and if you want to quick check if it is stored. So let me just press enter, and if you press the enter, you can see that here b is also now 30. So both, so these are the variables stored, and if you click on them, double click, so you can see that b, that 30 is stored to b. If you double click on a, so you can see that a 35 is stored to a. Now if I run the code again, So whenever I am running the code, you can see that this 35 is assigned to A, and that pops up. So if you, I mean, if you have large number of variables and if you run a code, so in command window, so this will always pop up, so that may be distracting for you. And so if you want to store the variable, but if you don't want to see the output, so what you generally do, you have to put the semicolon. So and so if you put a semicolon here and if you run it, so let me change it so that you can understand. So here you can see that A is 35, A is still 35. Now if I run the code, okay, so let me just delete it first because it is showing this error again and again. So now let me make it 45 and run it. Yeah. So you can see that once the script stopped executing, so this pops up, and you can see that A is now 45, but it is not shown in the output. So now if I make it 50 and if I remove the semicolon and run it again, so now you can see that it is showing the number. So if you want to suppress the output, but you want the number to be stored, or you want the variable to assign to the new value, so just put a semicolon after that. So if I make it 55 now, so you can see that in the workspace that A is now 35, A is now 55, but it is not showing here. So in that way, you can assign a variable, you can assign any number or any value to a variable. So now, suppose I want to take the input from the user. So how can we do that? So for that, we have this command input, and in the first column, you have to write this. So enter the number, and this is your input. So if you run it, so you can see here that the code is still working. So I mean, so when it is stopped executing, so this should popped up here, but it has not popped up because the MATLAB environment is waiting from the user to give an input. So if I give it 70 and press enter, then you can see that A is now 70 and the code has stopped executing. So now suppose I want to square the number, then what I will do? So A square. So for squaring, you have to put uh, this character, so that defines squared. So and if you want to see the output, then you will not put the semicolon, and if you want to suppress the output, then you will put the semicolon. Suppose I want to and I want to assign this to a new variable. So I can write b equal to a squared. So now let us look at the value. Before running, a is 70, b is 30. So if I run it now and I have to put a number, so let me put it 5. So what I will do, so b is still now stored as 30. That means this line haven't executed yet. So program is stopped here. It is waiting from the user to take the number. So once I pass the number and press enter, so look at the value of b in the workspace. So let me enter it, and you can see that b and a both has now updated. So in that way, you can take any input from the user, and you can define, you can do operations with them. So while working, you will have different types of data types. For example, so you can have integer number, you can have double precision number, you can have single precision number. So for example, if I have a integer value, so how can we define something as integer? So for that, you have to use this command int 16. Suppose 0.2. So and let me run it. So suppose you are storing it in C. So what will happen? So if I run it, so I have to first give the number to A. Yeah. So you can see that C is 100 now. So even though I have passed this 100.2, so what this int 16 does, so it basically converts this into an integer number and it store it in C. So now suppose I want to display this number. So I want to just suppress it and I want to display it. So for that there is this display command. So in the colon whatever you write, so that is considered a string. So and it will just out in output that will be just printed. So integer value of the user input is, and after that you can again write this. So what you want to, you will display C. So let me just remove, so comment this. So if you want to comment multiple lines, so what you can do, you will you have, so what are, so some, if you want to suppose comment first two lines, so you have to write this command. Yeah. So now MATLAB, uh, so it has turned green. So MATLAB environment will skip these lines and it will start from here. So and if I want to uncomment this, so you have to just remove the uh, first second bracket. So if you put it again, so suppose you have multiple lines here, and if you want to comment multiple lines in a with in a single go, so with that you can do, and if you click here again, it will be uncommented again. So and there is other way also. So what you can do, so you can select all the lines and you can press Ctrl R. But the advantage of the first process is that, I mean, so when you want to uncomment it, so here you have to I mean go to individual lines and remove this percentile sign. So it depends on your preference, which you what you want to do with your code. So I personally found this to be useful. So if I do this, so now the and here you want to, yeah. So now the first lines are commented out. So now it will start from here. So suppose you want, instead of putting this, you want to take an input from the user. So how you will do? So for input, you have to put. Let me assign a variable. For example, user input, and here you have to write this command input, and you will tell the user to enter a number. So enter a number, and you will convert this number to integer value. So here you are taking the input, and from with this int 16 command you are storing it, you are converting it in an integer number, and if you and then you are displaying this. So let me run it. If we run it, so first you have to enter a number. Suppose this is 20.67, and you can see the integer value, so it will go to the closest number. I mean 20.67, so it is closer to 21 rather than 20, so that is why the output is 21. And so if you want to, now, so there is this one function called floor. So what does floor function do? So if you I mean, so if you want to so let me check first. Yeah, so that will not work here. So because basically first it is converting it into integer number, then it is storing in C. So now if I want to show you the use of floor function, so let me just write it, floor user input. So what it will do, so let me just execute it and then explain it. Yeah. So what it is doing, so first the you are taking this input as 20.67, then float function what it does, so it basically give the closest integer which is lower from the input. I mean 20.67, so what will be the closest integer which is lower than that? So it is 20. So it will not go, it will not check which is closest both in the lower direction and upper direction. It will just check in the lower direction. I mean which integer is which maximum integer is lower than the user input value, so it will give you that function. So that is the use of the float function. And also you can convert an integer value to double precision value, so for arithmetic operation. So for example, you are taking this input and after that you are converting it into this integer function. So if I run it again, so let me take a number 243.5.2, so it will give you 245. Now suppose I want to convert this integer value to a double precision value, so for arithmetic operations and so on. So what will be the command for that? So for that you have to write down this command. So I will store it in another variable, for example, so let me call it as double l. So for that you will write down this double, so this is the command, and here you have to pass the number which you want to convert into double value. So let me run it again first. So this is the integer value, and you also want to suppose display the double precision value. So here you will write down just display. So here what you want to display, so what is the double precision value? Double precision value is stored in this variable, so you want to display this variable here. So let me put it down here and let me so suppose I am giving this number for 7. Okay, so integer value and this is the double precision value. So in that way you can I mean pass down any number. And if you want to check class of a variable, so for that what you want to what is the command? So you can write down class, and the and here you have to pass down the object. I mean whose class you want to know. So here suppose you want to know the class of this variable. So you can see here that the answer is double. So MATLAB is telling you that this is double precision value. Now if I want to know the class of C, so if I run it, so you can see here that it is integer 16. And there is this another command, so whose. So if you just type whose, so it will give you all the variables stored and their types. All the variables that is currently stored in workspace. So you can see that we have this A, this answer, this B, C, all this. So and here you can see what is A is double precision value, and B is double, C is integer, and so and if you want to know uh, the class of a certain variable, so suppose I want to know the variable A. So you will just after whose you have to give a space, and after that you have to put the number, put the object. So I want to know about A. So if I put A here, so you can see that what is the variable, what is its size. So generally when you are assigning any variable, so MATLAB always stored it in a matrix form. So MATLAB and
for a scalar number, so what is the row and column? So it will basically be one row and one column, so that is why the size is 1 comma 1, and this is the 8-bit number, and this is its class. So in that way you can know the type of a variable, and also all the variables that is stored in this in your workspace. Now suppose you can also now after that let me proceed with array. So whenever you are defining a function, you are defining a number to a variable, so it is, you can see that since its size is 1 cross 1, so it is stored as a matrix. So MATLAB always save any number as a matrix. So uh, now how to define a matrix, so let me proceed with that. So let me put everything in comment now. Yeah. And if you want to clear the variables that are stored in workspace, so you have to write down this command clear all in the command window, and if you run it, you can see that none of the variables are stored. Also you can put it in the beginning of your code also. So whenever you will run any code, so whenever you will rerun it, so it will first clear the workspace, and then it will execute the code. So I will recommend to put clear all in top of your code, so that you do not use any variables. So there can be some conflict. I mean, when you will do the programming, you will slowly learn, but it is best advisable to use this clear all and in the beginning of the code. And if you put this CLC, so what you will do, CLC basically clears the command window. So if you run it, so you can see that now there is nothing in the command window. So on top of each of your code, it is advisable to use these two commands. So let me put it in the top. Okay. And suppose now you want to proceed with, so now we will learn about array and matrix operations and so on. So suppose you want to define an matrix which has m number of, I mean 2, suppose you want to define a 2 cross 3 matrix. So what you will do, so if you want to create a matrix of 0, so for example you want to define a matrix of this type. So this is 2 cross 3. So there suppose so there will be, suppose 3 cross 2 matrix you want to define. So there will be 3 rows. So there will be a row, there will be second row, and there will be third row, and you have 2 columns. So there you will have a number. So in each of these elements you will have number. So this is how you define a matrix. So for example, if you want to now if you want to create an array, if you want to create a matrix where each of the elements are 0, so for example each of them are 0, and if you want to create a matrix where each of the elements are 1, so this is also 3 cross 2 matrix. Similarly, you can create matrix of other dimension also. Suppose you want to create a square matrix, 4 cross 4, where each of the element are 0. So how will your matrix look like? So you have 4 columns, all of them are 0, and you have 4 rows. So this is your matrix. So suppose you want to create this kind of matrix in MATLAB. So how you will do that? So uh, for that you have to write this command zeros, and after zeros you have to first put the row. So if you want a 3 comma 2, means so in the matrix there are 3 rows and 2 columns, so you have to pass here 3 2. So the order is important. So while programming, always the order is important. So first one is your row, and second one is your column. So if you run it, so you can see here, so there are 3 rows and 2 columns. Now if you want to create another matrix which has 2 row 3 column, so if I run it again, so you can see, that there is 3 rows 2 columns. So in that way you can define a matrix of number zeros. So for one you have this command. So if you pass down here 2 comma 3 and execute it, so now we can see that, okay, so for ones you have to write down this ones command and let me run it. Yeah. So now here what, so this step is important. So so when you are writing these 3 lines, so first what you will do, so first you can see, so whenever I am running it, first this 3 cross 2 matrix is stored in A where all the elements are 0. So first line is executed, and after that, so it will create a matrix B where there will be 2 rows and 3 columns, and after that after the third line, so here again it will override the initial value. So what you have stored initially, now since you have declared the variable same, so this once matrix, so that is stored in A and the initial value is overwritten. So if you click on this stored variables A, you can see that you will not able to find this because it is overwritten. So you have so while defining the variable name also, you have to be careful if you want to override it or not. And overwriting is very useful in, I mean, so you will learn when you work with this conditional statement and loop. So overwriting is very crucial in performing certain tasks. So be very careful about it when you want to overwrite a function, and if you don't want to overwrite it, you have to give a different name here. So uh, that's all about naming. So in this way you can create matrix of 0 of 1. So in that way, so you may think that if I write down 2, and if I run it, so it will create a matrix of 2. So if you just run it, it will not. So so these zeros and ones, these are inbuilt function in MATLAB with which it knows that it have to create an matrix where these numbers the user is giving is row and column. So MATLAB already environment already knows that. But so when uh, I mean mat there is no inbuilt command to create all the two create a matrix where all the elements are twos. So there is no inbuilt command for that. So that is why this error is showing here. So unrecognized function or variable. So when MATLAB this line will be executed, so it will search first. It will search. So for example, here it will first search 0. So zeros, it's already stored in its library, so it knows what zeros is, and similarly it knows what ones is. So it will just create this and store it in C. But when it comes to this line, the MATLAB, so it will first check if there is any variable assigned with, is there any function with you have created have you created any local function with 2? So first it will check that. So if that is not, then it will search its inbuilt library. So even so if that is not there even also, then it will give you this error unrecognized function and variable. So in that way, you have to be careful with these things, and you have to learn how to read an error. So reading error is very important. So because it also give you the line where the error is happening. So for example, there in line 28 you have this error, and what is this error? So unrecognized function or variable 2. So that suggests that there is no inbuilt library as 2's, and there is also no local function which you have created with the name 2's. So these are the things you have to be careful. So now suppose instead of this I mean zeros and one, you want to create a matrix where each of the numbers are different. So for example, you want to suppose create this matrix. So suppose C, and suppose this is a 2 cross 2 square matrix. Here you have -4, you have 5, 2, 1.2. So suppose this is the matrix you want to create. So for this, how you have to write it? Let me okay. So let me go to the MATLAB environment. So how you define this kind of matrix? So when you're so you have to write down. Uh, Suppose you want to store it in a variable, you have to first give the third bracket, and you have to the elements along the row. Suppose this is -4 and 5, so this is along the first row. And so how you will write this? So first you will write the 1 comma 1 element, then you will write the with the comma first you will write the second element, and then you have to go to the next column, next row. So these are the first. So for example, -4, this is the 1 comma 1 element, I mean first row first column element. This is first row second column element. Now you have to change the row and enter the numbers. So for that you have to put this semicolon. So whenever you are putting semicolon, that will take you to the next row, and then you have to write along the values along the column. So what are the numbers? So 2, 1.2. So if you run it, so you can see that this D. So now what you have created, since you have put a double number here, so it has converted all the numbers into double. So so whenever matrix works with single types of command, variable type. So if you are putting double here, so all the numbers are assigned as double. So if you just remove it, so now you can see that this is integer number now. So generally what it does, so if you put a double number, it converts all the number into this double precision. So if that is your matrix, so you are seeing this. So this is your output matrix. So if you click D here, you can see that this is the first row first column, this is first row second column, this second row first column element, and this second row second column element. Now suppose you want to know what is the I comma j element of a matrix. So for that you have to just simply write down I comma j. So I can be, so for example you want to know first row and second column element. So what you will do? So you have to put down the row first and column first. So what is D12? So your first row and second column. So that should be 5. So if you run it, so you can see that the answer is 5. So this way you can find any element of which you want to know from any given matrix with a single line of command. So in that case, so that is why MATLAB is very powerful in terms of this matrix operation. So now instead of this comma, you can also give a space. So comma and space both will work for uh, along the column, and for changing the row you have to give the semicolon. So both, let me create another array so that if you can understand that both gives you the same output. So this is the first elements along the first row, and then you have to write down the elements along the second row, 2 comma 2. And let me just separate this output. So if I run it, so they all of both of them, this D and E should be same matrix, because I mean space and comma both works. you can see, yeah, so both of them are same. Now you want to suppose what you will do if you want to create a 3 cross 2 matrix. So you will have 3 rows. So if you want to extend another row, so I mean you have to give a semicolon. So it will take you to the third row, and here you have to enter your number. So 0. I mean in the same environment, if here you can use comma. So put it 3. So let me give you the output. Yeah, you can see that there is 3 row and 2 column. And I mean you can give space, you can define comma, both works. And if you want to know 1 comma 3, just what should be 1 comma 3, it should give you error because there is no third column. So let me just run it and show you the error. Yeah, so index in position 2. So what is position 2? So here this. So first try to read the error. So where the error is, so this is the script problem 1 where the error is happening, and in line 31. So it is line 31. So these are line. And what is the error? So index in position 2. So where this is the index, it exceeds array bounds. So I mean you have created this array where the row there is 3 row and 2 column, and so that's why it is saying index must not exceed 2. So 2 is the column number, so you should not exceed 2. So by reading this error, you know the why it is not executing. So that's why reading error is always important to debugging code is the most important thing. So you can put 2 here. So you want to know third row first column number. So run it. Yeah. So what is the third row and first column? So it is 0. So it will give you output 0. Now suppose you want to uh, know, suppose and now if you are working with a matrix and you want to know what are the elements along the first row. So for that the command is, so you want to know the elements along the first row. So suppose you want to know the element first row and first column, so you will write 1 1. So if you want to know all the elements that are there in the column, so you have to put here this. So if I put this and run it, you can see that the answer is minus 4 5. So you if you store it, so val along first row, this is just the variable name. So it will for for understanding purpose. So what this do? So you are uh, storing all the values along the with first row and all columns. So if you run it, so you can see here this val along first row in the workspace. So what it has done, it has created another array where you have stored along the first row. If you want to store along the second row, you have to rerun it. So let me just suppress this outputs, and let me okay. So you can see that the second values along the second row is stored. Now suppose you want to do the inverse. You want to store of all the values along the all along the first column and all the rows. So that basically means first column and all the rows. So it should give you these 3 numbers. So let me run it, and you can see that it has created in that format, in that column format. Now suppose you want to transpose it. So what is the transpose command? So it's simple. So transpose. So transpose, and suppose I want to do the transpose of this. So I will for naming. So this is the variable name. So what do you have to? What is the command here? You have to give the matrix here. This is still a matrix, right? So this is 3 comma 1 matrix. We have 3 rows and 1 column. So just you have to give this. So if you I mean so if you run it now, and if you look at this, you can see that, so what are the lines doing sequentially? So first you are creating this array, Then this line will give you, I mean, 3 comma 1 element, and here what you are doing, you are storing all the values that are along the first column, and for all the rows. So this is the D matrix. So this is the first column, all the rows. So first you are storing all of them in this variable. So you are storing this minus 4 minus 2 0, and then you are transposing it. So you can see that this is a column matrix, and you can see that this is 1 cross 3. So this is a row matrix. So you can also transpose a, suppose I want to transpose the D matrix. So what you will do, you will just put this and see the output. So what is your D? So D is your uh, 2 3 cross 2 matrix. Now this trans D, this variable should be 2 cross 3 matrix. So run it, and let's look at the trans D. Yeah, so this is 2 comma 3. So D is a 3 comma 2, and it has done the transpose. So with a single line you can do the transpose. Suppose you want to know the inverse of a matrix. So suppose inverse of D. So this is a variable where I want to store the inverse, and what is for inverse, you have this simple command, inverse D. Will it execute? I mean, let us check. So we run it. Yeah. So for inverse matrix, we know that the matrix should be square, but D is a 3 comma 2. So what we can do, we can increase, we can make it square. So let me increase the number minus 2 and put it here 4. So now run it. Yeah. So you can see that the inverse has been created. So this is our updated matrix, which is a square matrix. I mean, for inverse, you have to have the square matrix. This is a square matrix, which is 3 comma 3, and from that you can create the transpose. Now suppose I want to know what is the maximum. So suppose I have this task. So let me write down the task first. So let me proceed with the problem set. So create 3 comma 2 matrix where all the numbers are chosen randomly between 50 to 100. So first you have to create this. Then the second task is so let me write down 1a, and this is 1p. So what it will do? So I mean, so you have to find the maximum along the, so for example, along second row. So let me make it 4 comma 5, larger matrix. So along second row, find the maximum, minimum, and the average of all the numbers, all the numbers along that row. So I mean, you have to, so what is the task here? So you have to create a matrix. There is 4 row, first row, second row, third row, fourth row. You will have 5 columns, column 1, column 2, 3, 4, So here you will have a number. These are your numbers. So there are so this should not be here. So okay, so here you have four rows and five columns, and for example, along the second row, I mean along this row, you have to find among this number which is the maximum, which is the minimum, and what is the average of these numbers. And also, I mean, this number should be chosen randomly from 50 to 100. So each time you will run the code, so you should see different output. I mean, so suppose for so let me show you how to do that. Okay, so for that you have to write down this command. So for example, capital A is your that matrix. So if you want to have a random number, I mean if you want to create a matrix, so for example 4 cross 5, so where each of the element is chosen randomly from 0 to 1, so for that you have to use this rand command. So if you run it, so you can see that it has created a 4 comma 5 matrix where row is 4 and column is 5, and each of the element is chosen randomly. So I mean, so why it is random? Because so now you can see 0.8147. If I rerun it again, it will change. So let me run it. So now you can see that the elements are changing. So with each run, you will see different numbers is being generated. So rand function is basically it choose a number from a Gaussian distribution, and for each run it will give you different output. Now the task is to create the matrix where you want to the number should not be between 0 to 1. So for that you have to write this function, and here in the third bracket first you have to specify the range. So for example, suppose you want to generate between 50 to 100. Let me run it. Yeah, now you can see that it is now every time you will rerun it, it will give you a random number between 50 to 100. So run it. You can see that numbers are changing. It also this is how you can create a random matrix of random numbers. If you want to create a scalar, you can either specify 1 here, so it will give you just one element, but still it is a matrix which has one row and one column. So if you look at 1, so it is 1 comma was double. And so for scalar, I mean you can give these two numbers or you cannot. So I mean both will give you same result, but for consistency, uh, you can verify this numbers here. So 1 1. So our task is to create 4 comma 5. So we have to write down here 4 5 and run it. So you can see that it has created this matrix of random number. And now suppose what I want to do, I want to know what is the maximum minimum along the second row. So for that what I will do, I will go, so I have to put the row here. So along this I want to know what are the elements along the second row, and I have, and what are so along column I will look for all the columns. So for that we know that this is what we have to write. So it will give us the all the elements along the second row, and suppose I want to store it in another variable x. So if I run it, so you can see that this is our, in this execution, this is our a, and these are stored, these are the values along the second row. Now if you want to know the maximum, just you have to write this simple command, maximum of x. So let me run it. Yeah, so you can see that what it will do, so it will check what are the values of x and it will look for maximum. So similarly for minimum, you have to write down just min. run it. You can see what is x, this 77, 78, 65, 59, 72. So what is the maximum? That is 78. And what is the minimum? That is 59. Okay, now you want to know what is the average. So for average, when you have to first sum all the numbers of x. So it is summing all the elements and it gives you this. And after that, what you have to do, you have to divide it with the number of elements in x. So how can you know the number of element in x? So for that you have to write, there is this command length of x. So what should be the length of x? I mean there are 1, 2, 3, 4, 5. So there are 5 elements in x. So if you run it, so there should be 5 elements. So you can see that the length is 5. So for average, what you will do? Average of x. So you will just divide, so this sum. So that is why I mean you have to divide this sum with this length. So that just gives you the average. So this is how you can I mean know what is the average. So let me just give some variables. So this is max of x, and this is mean of x. So these are the variable names. This is sum of x. This is length of x, and average. What you are doing? So you are basically dividing the summation with the length. So let me suppress this because you want to know what is the maximum, what is the minimum, and what is the average. So these are question. So if I run it, so these are matrix which is randomly created from 50 to 100. This is 4,5. So you're looking along the second, you're finding the maximum, finding the minimum, and finding the average. I mean you can go along the fourth row, you can go column wise, and also you can find what is the maximum element of the whole A matrix. So for that you have to put A here. So let me, so this is the A matrix. So what is the maximum element here? So maximum is 100. So the output, this output should give us 100. So let us check. Okay, so this max command, so if you are doing it with a m cross n matrix where both of them are greater than 2, so it basically gives you the output along the column. So first it will look all the elements along column 1, and it will give you what is the output is. Then it will look along the second column, and it will give you what is the maximum number is. So and then it will look along the third column and give you what is the maximum number is. So in that way you can create an array of maximum numbers, I mean along column wise. So if you want to now so if I look at this max array, max x array, let me look at it here. Yeah. So here you can see that what is our a, let me look at the a array first. So in this max array, so first it will check for all the elements around the first column and assign the maximum value here. So it will doing the column wise operation. Now if you want to do the row wise operation, suppose you want to know what is the maximum number along the first row, and then what is the maximum number along the second row, and want to store them in a array. So for that you have to pass down here 2. So let me run it. So these are a. And so what should be the max x array would look like? So what is the maximum along the first column, along the first row? So that is 94, and in the second there should be 100, and in the third there should be this 80, and in the fourth there should be this 93. So let me check. Uh, Okay, so for row-wise operation, I mean, you can individually store them in an array and you can look at the maximum. So, I mean, there is maybe not in inbuilt function, so I will look at it. I will and I will discuss it in the in the next class if there is any function. But that is how you can work with any matrix. You can look, you can store all the elements row wise, column wise. You can find maximum, minimum. You can summation it. You can, I mean, find the average along the row, along the column. So all this you can do the transpose. You can do the inverse, and also you can find the determinant of a matrix with a single command, which is, so let me write down the command. So date a, it should be, yeah. Okay, so the matrix should be squared for determinant. So let me create a 4 cross matrix, and in that way you can, I mean, create the determinant of a matrix. So you know how to do the inverse, how to do the transpose, how to get the determinant, and how to. So also similarly, you can find the uh, eigenvalue of any matrix with a simple command. So for eigenvalue, okay, so I will discuss the eigenvalue later. So first, let me tell you the operations. I mean, you can define two matrix, and you can do how we can add them, subtract them, multiply them, and divide them. So let me create. So let me put all of them in. Okay. So now let me run. Everything should be fine. Yeah. There is no. I mean, everything is in commented out. So let me start fresh here. So clear all CLC, and after, yeah. So first you will create an matrix 4 comma, suppose 4 comma 5, and you will create another matrix, and so you want to do how to do operations with two matrix. So you're creating, suppose, a random number from 1 to, I mean, if you put rand, it will basically do, even it will produce numbers between 0 to 1, and then you have to pass the row and column. So there are, suppose, 4 row and 5 columns. Now if you want to do the, I mean, summation, so you have to just so matrix summation. So we're doing the matrix summation because these two are matrix. So a plus b. So what you will do, so let me run it. So this is your A matrix, this is 76, this is 0.4714, and this is your summation. And similarly, you can matrix substitute. So let me first define the operations and then I will execute. So this is how matrix subtraction should look like. Matrix multiplication, and you know, in matrix multiplication the order is important. So I will just right now A, type this A B, and you have this matrix division, so A divided by uh, B. So which are the operations that should not execute? So if you know, for matrix multiplication, the column number of first matrix and the row number of the second matrix should match. So if I run it, so you can see that it is giving summation, it is giving subtraction. So here error using dot. So incorrect dimension. So what is the error number? 54, which is what we have guessed. And what is the error? So incorrect dimension, which I have discussed. So check that the number of columns in the first matrix, which is 5, that matches the number of rows in the second matrix, so which is 4. So it both of them should match, or so it will not give you the output. Now what I have done, so I have put a dot here. So what does this dot mean? So dot means basically element wise operation. So you have these two matrix, so there is 4 comma 5, this 4 comma 5, and what this element wise multiplication does, so it takes this first first row first column number, here also the first row first column number, and multiply them. So it should be around 20, uh, yeah, around 20 something. So it is not doing the traditional matrix multiplication, it is taking individual numbers and multiplying them. So if I change them, so now what will happen? So this matrix summation will not work because their dimension should match for summation. So you have to be careful about this summation, and here also for individual operation. I mean you for I mean for 4 cross 5 and 4 cross 5 you can do the individual multiplication, but 4 cross 5 and 4 cross 6 you cannot. So because there is, I mean, this number will be multiplied with this, and here 91 will be multiplied with this number. So in the similar manner this 66 will be multiplied with this, but then I mean there is no element in A which would be multiplied with this, so that is why it is giving you an error. So I mean if you want to I mean you have to be careful which operation you want to do. So if you want to do the uh, element wise operation, so that you can do with this dot command, and if you want to do the traditional matrix multiplication, then you have to remove this and you have to do the multiplication command. So here you will get the error. So for 5 4 comma 6, so now if I put it 5 here, so that will execute the traditional matrix multiplication. And what should be the output? I mean this 2 now will give me error. So you can see that these are matrix multiplication. I mean it is doing the, so 4 comma 5 and 5 comma 5, it should give us 4 5 4 comma 5 order matrix, which is giving. And this is the how the matrix division will look like. So if you want to do individual division, you can put here division. So 4 comma 5 4 comma 5. So let me do the individual operations. So this is how individual operation will look like. So it will, what it will do, it will divide the 83 with this number, then it will, I mean it will divide this 64 with this number. So it is doing the individual operations. So and also you can so let me comment this, and also you can raise an matrix to any power. So for example exponential a, so what it will give, so this is our a matrix. So this exponential command, it will it will make the exponential of each of the individual number. So the second, so if I store it in C and run it, so what is the, I mean the first row and second column element of A is 25. So the first row and second column element of C would be the exponential of that, and this is the first row first column element. So this is how we can check, so this is the corresponding numbers exponential of that. So you can do exponential of each of the numbers. Now you can square a matrix also, to the power 4. So it if you run it, so here, so if it will give you error because if you are not defining the dot product, so if you want to raise individual element to the power 4, so you have to put this individual uh, here. So here what it will do, so it will take the A matrix and make all the elements, raise all the elements to the power 4. So give let me explain you here. So you have this, suppose A matrix which is 2 2 1 0 4 5. So what does this, and suppose we have another matrix which is 1 1 2 minus 2 3. So if you do the traditional matrix multiplication, it will not work because this is 2 comma 3 and this is 2 comma 3. So this will not work. But if you do the individual operation, if you want to do the individual multiplication, then you have to write this A dot star B. So what it will do, so here it will look for the first row first column element which is 2 and the first row second column which is 1 and multiply. What is the first row second column element? That is 2, and first row second column, that is 1. So it will multiply it, and this is 1 2. So it will multiply, do the individual operation here. It will do the individual operation here also. 0 minus 2. Here we have 4 comma multiply with 3, 5 multiply with 4. This is how A dot B is defined if you do the individual operation. So what should be the output will look like? So 2 cross 1 is 1. This is 2 2 2 0 12 20. So this is how you can do individual operation. You can do the divisions also. So when you will do the division, so here this multiplication will be substituted with division. For individual division, you have to be careful, because if there is any element in the in the B matrix, if there is any zero element, so then you are dividing with 0, so that will give you, ideally, it will give you infinite, so in the code you will get some error. So for that you have to put some condition in the matrix, which in the MATLAB environment you have to define a condition. MATLAB doesn't know that how to deal with it. So you can tell that if there is any zero element, so add a little bit of offset to it. So that we will learn in the next class, how to implement this condition. So this is how we can do matrix operation. So you can do the so now you can similarly you can do the A to the power 4 here also. So A to the power 4 individual operation means, so when you are doing this individual operations, so that basically is A multiply with A multiply with A. So first it will do the individual operation, so that will still be a 2 comma 3 comma 2 matrix for our example. Then this 3 comma 2 will individually multiply with this A, so that should be still a 3 comma 2 matrix, and this whole matrix will again be multiplied with A, and that should still be a 3 comma 2 matrix. So, and in the same manner, exponential, why does it work? So exponential, you know that you can expand it as a as a series function. So 1 plus some coefficient power of a, power of a square, power of a cube, and so on. So what does this exponential operator that is defined in the MATLAB it works? So first it will do this individual operations, a square, a cube, all the powers, and it will just keep on adding them. So all of the this a squared, a cube, these are of same uh, same dimension matrix, so you can add them, and in that way you can get the exponential of any function. So yeah, so these are the example of and use cases of matrix and array. So today we have learned the very basic things. So how to define an array, how to do operations with it, how to do inverse an array, how to find out the determinant, and all of this. So let me check with the last thing which I have left is eigenvalue. So if I want to know the eigenvalue of A, you have to write down this I command. Okay, so for eigenvalue, we have to have the square matrix again. Okay, so here you can see that these are the eigenvalues, and you can also get the eigenvectors. So if you write here, eigen, so you will store this. So eigenvalue you will store. So basically, this the function that is built in MATLAB. It gives you two output. So one is the eigenvalues, and another one is the eigenvector. So eigenvector of A, this will give you eigenvalue. So if you run it, you can see that these are the eigenvalues, and here you can see that these are the corresponding eigenvectors that they are returning. So you can look at you can know what are the eigenvalues and eigenvectors of a matrix also using this command. So yeah, so these are the things that we have learned today. So we have learned how to save a function with name, how to what are the potential name that you can avoid, and what is this workspace, what is this command window, and how to define a variable, how to know the class of a variable, and also how to define array, and what are the operations with it. How you can find the maximum, minimum, how you can create matrix, you can select individual row, you can select individual column, you can do also you have learned matrix operations also. So these are the very basic fundamentals. So with that, so let me just show you the last problem, and next in the next day I will do the same problem using this conditional statement. So so suppose you are given a problem that you have to find the square uh, of the first 10 integers. So so for that, you can do in this way. So a equal, so what is the most brute force method? So you can make them, you can store all the numbers. So these are our integer numbers, and in this way you will go up to 10, you will square each of them, and you will again store in a matrix which will give you the output. So this is the most brute force way. Next, what you can do, you can use array. So for that, how you can do that, so you can store them along a single row. This is our suppose a matrix. So these are a matrix, and if you want to know what is the square of each of the individual element, so if you want to do individual element operation and want to square it, so then what you will do? You will do this. You will write this command a dot star square. So you can see that 1 square, 2 square, it is doing all that. So you can store it in another variable. Okay. So yeah, yeah. So this is fine. Now suppose you want to know the square root of the first 100,000 numbers. Then what you will do? You will type this 11, 12, up to 1000. So will you do that? I mean, there must be some alternate ways. Okay, so in the next day, we will learn how you can use this conditional statement and loop to write down these numbers and to do this kind of operation. I mean, each day everything will be accumulated. So the things that you learn today, so that we will use the next day, and we will use some more functions. So in that way, we will slowly go into more complex problems. So first, today we we have learned about basic matrix operation, how to store matrix, how to create array, how to find maximum minimum, and how to define variable, and so on. So okay, so with that I will finish today's class. So and yeah, so see you in the next class. So if you, I will give a problem set based on today's lecture, and all of this codes and all of these things. So I will upload it in a drive folder, and I will share the drive link with each all of you. So okay, so see you in the next class.